to True Projects. In this video, we are going to explain about a project titled Dynamic Embedding Projection Gated Convolutional Neural Network for Test Classification. Test classification stands as a foundational task in natural language processing, where the broad practical implications encompassing the sentiment analysis, spam identification, and the topic categorization. Throughout the time, a spectrum of machine learning and the deep learning methods have been advised to address this challenge, delivering the remarkable outcome and influential strategy that has garnered the notable interest recently in the CNN. In this study, we introduce an innovative deep GCNN architecture for the test classification where each facet of the model assumes a pivotal role in adeptly acquiring and encapsulating the evolving embeddings. A distinctive facet involves a dynamic embedding projection layer, facilitating on-the-fly updates to the word representations guided by the contextual cue. Additionally, we employ a gated mechanism within the convolutional layers, indiscriminately preserving the information pertinent to the classification objective, and this pioneering approach showcases the potential for refining the test classification performance. And introducing an innovative stride in test classification, we present the dynamic embedding projection gated convolutional neural network tailored for both the multi-class and multi-label scenarios. This harnesses the gating units and the shortcut connections, skillfully regulating the infusion of contextual insight into the distinct sequence of a word embedding matrix within a test. This architecture seeks to tackle the persistent complexity observed in the prevalent test classification system, which often falls short in either accuracy or the shift in convergence during the training. Remarkably, the DAP-CNN model advances the performance benchmark set by contemporary counterparts, as evidenced by comprehensive experiments conducted across the core benchmark dataset. This advancement holds the potential to reshape the test classification paradigm, effectively balancing the precision and efficiency in a unified framework. And these are the basic requirements that are needed to build this project. The software requirements are Python IDEL with version of 3.7, Anaconda with version of 3.7, or Jupyter Notebook. Hardware requirements are operating system as Windows, processor of minimum Intel i3 and above, RAM of minimum 4 GB, hard disk of minimum 250 GB. And to know about the flow of the project, these are the steps we need to discuss. The first one is importing the packages. Essential Python libraries are imported, including Pandas, NumPy, and sklearn for the data handling and machine learning, and the frameworks like TensorFlow for the neural network development. And the next one is loading the dataset. The designated dataset for the test classification is loaded into the memory. This step involves reading the data in a suitable format such as CSV or JSON. And the next step is data processing. It ensures the encompassing step like dealing with the missing value, handling the outliers, and ensuring the data uniformity for the effective analysis. And the next step is visualization using Seaborn and the Matplotlib. Seaborn and the Matplotlib are employed to visually inspect the data distribution relationship between the features and the potential pattern. Visualization like histograms and scatter plots we offer available to the insight. And the next one is tokenization. The raw text data is transformed into the numerical format by tokenization, wherein sentences are split into the words or tokens forming a structured representation amendable for the further processing. And the next step is feature selection. To streamline the model training and enhance the performance, relevant features are chosen, while irrelevant and the redundant ones are discarded. And the next step is data splitting to the train and the test. The data set is divided into the training and the testing set. One is for training the model and the other for assessing the predictive performance. And the next step is building the model. Several models are crafted for the test classification. The first one is logistic regression. It is a classic linear classification algorithm that's well suited for the binary and the multi-class classification task. And this project allows serve as a baseline model. It learns the relationship between the input features and the class label while calculating the probability and making the prediction based on the logistic function. And the second one is SVM. Means of support vector mission is a powerful linear or the non-linear classification algorithm that aims to find the optimal hyperplane or the decision boundary that maximizes the margin between the classes. SVM can handle both the linear and the non-linear relationship in the data, and this project SVM can potentially capture intricate decision boundary in the high-dimensional feature space. And the next one is voting classifier. It combines the prediction from the multiple base models, and in this case logistic regression, random forest, as of twice. This ensemble approach aims to leverage the strength of the different models and improve the overall prediction accuracy. And the next one is regularized LSTM. It extends the standard LSTM model by incorporating the regularization technique like dropout and the weight decay. And the context of this project, regularized LSTM introduced the mechanism to prevent the overfitting and enhance the generalization. And the next one is CNN. CNN is a deep learning architecture renowned by its effectiveness in the image processing. And the test classification, CNN processes the textual data by convolving over fixed size window of words to capture the local pattern. This approach can extract the meaningful features from the sequence of words, which is particularly useful for the short test snippets for pixel length inputs. And the next one is CNN plus LSTM. Combining the CNN and LSTM leverages the strength of both the architecture. It captures the local features in the test data and the LSTM model long-range dependencies. In this project, this hybrid model can potentially enhance the understanding of both the short and the long-term pattern in the test sequences, leading to the improved classification performance. And the next one is attention-augmented LSTM. It enhances the LSTM ability to focus on specific part of the input sequence that are more relevant for the classification task. It assigns the varying weight to different time steps, allowing the model to give more attention to the crucial element. And the next one is dynamic embedding projection gated CNN. It introduced an innovative architecture by integrating the dynamic embedding projection and the gated mechanism within the CNN. This novel approach adopts the word embeddings based on the context, enriching the representation, gating units control context incorporation. It seeks to address the existing challenges in the test classification model, potentially leading to the enhanced precision and the convergence rate. And the next one is user gives the input. User input are facilitated through the Flask web-based interface, allowing the user to enter the test for the classification. And the next one is the given input is translated and pre-processed for prediction. The user input is translated into the format compatible with the model, undergoing tokenization and the other pre-processing steps just like the training data. And the next step is trained model is used for the prediction. The pre-processed user input is fed into the trained model where each model leverages its learned pattern and the connection to predict the classification outcome for the given output. And the last one is final outcome is displayed. The predictions from the models are collected and presented as the final outcome. Users receive the information regarding to the predicted class or the label for the input test, aiding the decision making and understanding the model behavior. And the execution of the project. To execute the project, first we need to open the code folder, and this is the code folder. And this is the code folder containing of various files within it. These are the test data that we used in this project, and it is also the data set, and this is also the data set that we used, and the static folder containing of the images, CSS, fonts and assets folders within it, and the template folder containing of the typical HTML documents, it containing of results, sign in, sign up, index pages within it. And the app is an py file which likely contain the information related to the front-end logic. It includes the code written in Python that handle the server-side operations such as processing the user request, interacting with the database, and generating the dynamic content that to be rendered in the HTML template. And models are SAV files which contain the information related to the algorithm and is loaded into the project code during the runtime to utilize the trained model for the various tasks, such as making the prediction on the new data, performing or specifying the new task. And the notebook is an IPYNB file which contains the information or the combination of code, graph, and output all in one place. It allows the user to write and execute the code in individual cell, making it a popular choice for the data science. And the signup.db is a file appeared to be the database file that will be used to store the user information. And for the execution of the project, first we need to copy this code folder path and then open the Anaconda prompt. Here we need to write a command that is cd space and paste this code folder path. By this it will change the current directory to the code folder path, and then we need to write a command that is python space app.py. By using this command, it will execute the Python script and perform the runtime check for any syntax errors or logical issues. And then click on the enter button. After running this app.py file, the Flask framework will host the application locally at the default address like this. We need to copy this link and paste it on any of the web browser of our choice, and I prefer to use the Google Chrome. I'm pasting this link and then click on the enter button. After it redirected to this page containing of some information about it and of home and sign up buttons. Click on the sign up button. Here it will redirect to the sign up page containing of some necessary details that are need to be created to create an account. But my account is already created, that's why I'm using the sign in button. Here it redirects to the sign in page containing of the username and password, and I'm filling those details and then click on this login button. Here it will redirect it to this page, and here we need to enter a message. As I'm entering the message, I would put this as of my list of fillings in the category of unwatchable trash. At the top of my list. They are films that are bad, but the worst kind are the ones that are unwatchable. And then click on the predict button. Here the result is predicted as the given IMDb review is of negative. And then click on the IMDb button. Here it redirected to this page, and here we can enter the other message as right from the start. You see that Anchors has great comedy, Jenny Kelly make so much, make such a funny deal. The songs they sing together a pure entertainment. And then click on the predict button. Here the test is predicted and classified as the review is positive. And by clicking on the news type button, here we can re-enter another message too. By this we can recognize the type of news. Here I am entering the message as of still no movement in NHL labor talks. The NHL and the Players Association moved no closer to a collective bargaining agreement during a 5-hour meeting. And then click on the predict button. Here the news is classified as of the sports based news, and by clicking on the news type, here we can enter the other message and classify its news type as of the message. In this way, we can classify the test by using the various machine learning models. And in conclusion, the dynamic embedding projection gated convolutional neural network for the multi-class and multi-label test classification. The deep CNN model uses gating units and the shortcut connections to control how much context information is incorporated into each specific position of a word embedding matrix in a test. The experimental result on the 4 benchmark datasets show that deep CNN outperforms its recent peers. We conclude that DEP-CNN is an efficient neural network model for the test classification that can selectively control how much the context information is incorporated into each specific position by converting a word embedding matrix and delivering it.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.